So yesterday we introduced the idea of a limit, and with what we go over today, I hope we start to solidify our understanding about how limits work, both graphically and in a table. So to start things off today, we're going to formally define what a limit is, like how do we know when a limit exists, and we're going to say an overall limit, this is kind of my wording, an overall limit exists provided the left and right limits approach the same real number. Okay, so in order for us to figure out if an overall limit exists, we have to examine both sides of a function and see if they would eventually meet, or at least seem that they would meet or match up with each other, and make sure that the height that they would match up is a real number. So we're going to take a look at some examples today to kind of hone in this idea for us to get an understanding of limits. So taking a look at our first one, we're going to evaluate the limit as x approaches 2 from the left. So let's first find the x value of 2, which happens to be this vertical asymptote, and if we were to approach that vertical asymptote from the left-hand side, notice how our graph continues upwards forever. So the y value that we would be approaching would be positive infinity. Similarly, if we look at the right side of 2 and trace our graph, it will go upwards forever, so that y value is also positive infinity. So limits deal with this idea of approaching. If we take a look at part C, this notation is asking us for a function value, meaning if we were to actually plug into, what would we get out as a y value? So we approach infinity from the left and the right, but if we actually tried to plug into, notice how we would get an undefined or a does not exist solution because we have that vertical asymptote there. So notice the difference between the two. Limits are dealing with what you're approaching on either side, whereas a function value is what you actually equal at that point. So this is going to bring in the idea of an overall limit. Notice how this notation, the limit as we approach 2, there is no plus or minus sign in the exponent spot like we had previously. So this is signifying an overall limit. Meaning, do the left side of 2 and the right side of 2 actually meet up? And if we look at what we wrote previously, the left side of 2 goes up forever, the right side of 2 goes up forever, we might think that they would meet or approach at some point because these numbers are the same, but infinity is not a real number. Okay, so we would have to say no, because infinity is not a real number. So in order for a limit to exist, it has to meet two criteria. The left and the right sides have to approach the same number, but that number must be a real number, either a whole number, a decimal, or fraction, whatever the case may be. Let's try the next one. So find each of the following. Let's approach 2 from the left. So here's our x value of 2. If we trace the left side of the graph, notice how we would be approaching the whole, and the whole has a height of 2. If we trace the right side of the graph, we are also approaching the whole, which again has a height of 2. So limit values are what you are approaching. Part C is asking us about a function value. If we actually plug into, what would we get out as a y value? And notice how that would be -3, because that's where our closed circle is located. So I think this is a good example to clearly see the difference between limit values and function values. Let's evaluate the overall limit at 2. So we approach from the left, we approach from the right. It looks like they would be meeting up at the same spot, okay, because notice how we both said they were reaching a height of 2, and 2 is a real number, so the overall limit is 2. Yes, because the left and right limits both approach 2. Looking at our last one, find each of the following. So we're going to approach 2 again. First one, we're going to trace the left-handed graph. Notice how we get closer to the closed circle, which has a height of 3. If we trace the right-hand side graph, we're going to get closer to the hole, which has a height of -3. If we were to actually plug in 2, instead of just approaching it on either side, we would have a function value of 3 based on the closed circle. So if we take a look at the overall limit at 2, notice how the left-handed side and the right-handed side did not approach the same value. So our overall limit would not exist. So no, because the left and right limits don't match, meet, have the same value, whatever wording you want to use.